So remember yesterday we talked about reference angles. We just reviewed it from a past unit, and I just want to formally write the definition before we move on to the actual solving of reference angles. So remember that a reference angle is an angle between 0 and 90 degrees in any of the four quadrants, either quadrant 1, quadrant 2, quadrant 3, or quadrant 4. And in the previous video, I gave you the formulas, and I just want to empathize with you guys. Like, if you're great at memorizing formulas, by all means, I'm not taking that away from you. But for a student like me, because I was always really, really good at math, but only if I could explain it to myself in a way that made sense more than just, oh, plug it into the formula. For me in geometry, I always struggled with this. So if I go back in time to the year 2003, 2004-ish, I would tell myself this. Here's some helpful hints if you want to solve for the reference angle. Well, for the first step, I would draw the angle itself. So if I were to, for step one, I would literally draw the XY plane, or the Cartesian coordinate plane, and I would start here. And depending on where the angle landed. So if it was in quadrant 2, quadrant 3, or quadrant 4, let's just say I put it in quadrant. If I put it in quadrant 2, I would draw the line that connects it to the origin, and then I would label the angle theta. Okay? If it was in quadrant 3, oops, I can't. There we go. If it was in quadrant 3, I would start right here, draw it in quadrant 3, and sandwich it with the x-axis, and then draw the angle. And finally, if it was in quadrant 4, I would start here, draw the angle, and then sandwich it with the x-axis and draw the angle theta. So once again, if you're the type of student that does not benefit from here's the formula, draw a picture, sandwich it with the x-axis, and use your critical thinking skills to solve for angle theta. Because the key is to sandwich it with the x-axis, not the y-axis. Okay, so let's get some problems in there. So problem number 1. Find the reference angle and then specify the quadrant. So why don't I get my calculator ready? So remember, I start here. Right, I'm just darkening it just to show it for the video. You don't have to literally just darken it like like stab it through the paper. But remember that we are drawing an angle 130 degrees. It is past the 90 degree mark for sure. Not quite 180 degrees, so it's in quadrant 2. And I want to sandwich it with the x-axis. So I sandwich the terminal point with the x-axis, so the angle theta has to be right here. Now, if you look at your quadrant 2 formula, that means that the angle theta must be completing the quadrant 2 angle to form 180 degrees. Or if you go back to your vocabulary, the reference angle and the quadrant 2 angle must be supplementary. So that is 180 degrees minus 130 degrees. Or angle theta is 50 degrees, and we are in quadrant 2. So what we can do is we can check the 50-degree angle, sine and cosine, and compare that to the 130-degree angle quadrant, the 130-degree angle cosine and sine. So let's do that. So I'm going to do the cosine of 50 degrees and the cosine of 130 degrees. Notice I don't really care too much about what the decimals are, but I care about, are the digits very, very similar? Yes. So approximately, let me just get some squiggles, 0.642 2. It doesn't care. I'm not expecting this for the. This is the important part, right up here. This is the check the work part. And remember that the same exact decimal happens in quadrant 2, but remember that in quadrant 2, the x-coordinate is negative, so the cosine has to be negative as well. I'm going to check with the sine of 50 and the sine of 130. Let's do that. So I'm going to compare these two trig ratios. The sine of 50 is 0.766, and the sine of 130 is also 0.766. So that checks out the two main requirements. That the digits have to be exactly the same, and that the cosine is negative and the sine is positive. This is to check your work. It's not required. Okay? All right. 260 degrees. Well, how do I do that? Well, remember that I start here. If this is 90, 180, 270, 360, 260 doesn't quite match, doesn't quite pass 270. So if I were to draw, it would be around here. It's not perfect, but you get what I mean. So that's where my terminal point theoretically would be. And remember, I want to sandwich it with the x-axis, so the reference angle would be here. So if you go to your 4 formulas, since we're in quadrant 3, we have to use the quadrant 3 formula. Well, if it sandwiches it with the x-axis, this is more than 180, and I want to figure out what this part is, so I'm going to take away 180 degrees. So the reference angle is the quadrant 3 angle, which is 260 degrees in this case, minus 180 degrees, and that leaves me to believe that 60 minus 180, that would be 260 minus 180, that'd be 80 degrees, and we are in quadrant 3. Okay. Now, how do I check my work? I compare the reference angles cosine and sine with the given angle, 260. And once again, I'm not going to care too much about, do you know the cosine and sine of 80 degrees? No. But I care about whether the digits are similar and that their positives and negatives act accordingly. So since it's in quadrant 3, what do we know about the cosine and sine of quadrant 3? My theory is that they're going to be the exact same digits, but the cosine and sine of 260 are both going to be negative. A negative cosine and a negative sine. So let me just get my squiggles ahead of time. So the cosine of 80 and the cosine of 260. Compare. So the cosine of 80 is 0.173, and the cosine of 260 is negative 0.173. Look at that. So far, so good. Let me compare the sine of 80 with the sine of 260. The sine of 80 degrees is 0.984, and the sine of 260 degrees is negative 0.984. So that looks like a big old success to me. Even though this is the part that I care about. The drawing the picture part is a nice touch, but you don't need to do this part unless you're really really paranoid. Like, did I do this right? Which I was that type of student back in the day. So let's do 8 more problems and then we'll call it a day. Okay. So 350 degrees. Yeah, you can see where my mind was. I was like, you know what? We need this kind of angle. So let's darken this right part of the x-axis. And remember, this is 90, 180, 270, 360, and it's just shy of a full rotation. So let's just say 350 degrees is right there. It's not perfect, but the idea is if I sandwich this terminal point with the x-axis, I need to figure out what this angle theta is. So I use my quadrant 4 formula, or I notice that in order to complete this circle, I need whatever 350 degrees is. I need 350 degrees plus angle theta to complete a full rotation. Therefore, this angle theta can be found by taking 360 minus the given quadrant 4 angle. 360 minus 350 is 10 degrees, and we are in quadrant 4. So we're going to look for the reference angle to match up with the 350 degree angle. So let's do that. So let's explore some theories. What do you think are going to be the cosine and sine of 350 degrees compared to the 10 degree angle? So since we're in quadrant 4, the cosine must be positive, and the sine must be, since we're below the x-axis, it has to be negative. So my theory is it's going to be a positive cosine and a negative sine. So let's get these out of the way. 0 point, 0 point, 0 point, 0 point. Okay. So let's compare the cosines first. The cosine of 10 degrees and the cosine of 350 degrees, I bet you they're going to be exactly the same. Positive 0.984, positive 0.984. You've made me happy. So that checks out. And now I'm going to do the sine of 10 degrees and the sine of 350 degrees. And I get positive 0.173, negative 0.173. And that satisfies all my requirements necessary. I did it with the formula, I did it with the picture, and I did it by comparing the cosine and sine of both angles. So therefore, 350 degrees forms a 10 degree reference angle in quadrant 4. 47 degrees. Where is 47 degrees? 47 degrees is about right here. And remember, we are in quadrant 1. Hey, 47 degrees ends up here. How do I form the angle in that quadrant? Well, 47 degrees is 47 degrees. So that reference angle is 47 degrees in quadrant 1. Once again, an angle in quadrant 1 is its own reference angle. Okay? Now then, see if you can do number 5 and number 6 independently. Okay. So let's take a look at number 5. And again, you don't have to do the cosine and the sine at the end if you don't want to. If you trust your math skills, be my guest. I'm just doing this so that you can get another safety net underneath you. So if we've got the 295 degree angle, so once again, I'm starting over here. 90, 180, 270, 360. 295 is greater than 90, greater than 180, and greater than 270, but not quite a full rotation. So it ends up around here, I'll say. It's not perfect, but the goal is you know that it's in quadrant 4. Waka, 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 waka. So if my 295 degree angle ends here, I want to sandwich it with the x-axis and form that angle theta. So I go to my quadrant 4 formula and notice that my angle theta is 360 degrees minus my quadrant 4 angle. If 360 minus 300 is 60, then 360 minus 295 needs to be 65. So my angle theta is 65 degrees, and I am in quadrant 4. And if you don't believe me, you can always check the cosine and sine of the reference angle with the cosine and sine of your given angle. So I'm going to do the cosine and sine, the cosine of 65 and the cosine of 295. Oops. Cosine of 65, cosine of 295, and I'm going to compare both of them. They're both 0.422. And I'm going to compare the the sine now, sine of 65 degrees, and the sine of 295 degrees. And I get 0.906 for 65 degrees, and negative 0.906. So if we look at the behavior of the cosine and sine in quadrant 4, then we see both requirements. The cosine needs to be positive, and the sine needs to be negative, and they're respectively same digits. So now, see if you can do number 6. Oh, I already said that. Well, look at 95 degrees. Here's 90. And then I have to sandwich it with the x-axis, so I'm technically in quadrant 2. Sorry, I looked at this and I was like, wait, did I do this right? And I was like, oh, wait a minute, yeah. If this is 90 degrees and it's not quite 180, then I have to sandwich it with the x-axis. So I'm going to do theta is equal to 180 degrees minus 95 degrees. And now I'm going to use my critical thinking skills. 180 minus 95. Well, if 180 minus 100 would be 80, then 180 minus 95 should be 85 degrees. And we are in quadrant 2, so we say 85 degrees in quadrant 2. If we check our, you can do this independently, but I'm looking at the clock. You can check your work by applying cosine and sine of 85 degrees and 95 degrees, and they should have a negative cosine and a positive sine. I'm filming a video right now. Okay? I'm sorry. So let's take a look at 7, 8. Sorry, I got a phone call. No, I got 2 phone calls in a row, and I had to say I'm filming a video right now. So let's check 7, 8, 9, and 10. Okay. So I'm going to look at this. Where am I for 14 degrees? 14 degrees is, again, it's just enlarged for scale, but remember that the angle theta formed is in quadrant 1. So 14 degrees is 14 degrees in quadrant 1. Where are we for 142 degrees? Remember that this is 90. 180, 270, and 360. In other words, if I were to draw this angle, it would be past 90, not quite 180, and I don't care too much about, oh, you're more than halfway or you're under halfway. Just show me that you're in quadrant 2. And we want to sandwich it with the x-axis, so I'm going to put the theta right there. So this theta has to be 180 minus 142, and I'm going to use my mental math skills. 180 minus 40, 180 minus 140 would be 40, and because I've got to do 180 minus 42, that'd be 38. So remember, we're in quadrant 2, so 38 degrees in quadrant 2. Brr, that's cold. Okay. Number 9. 187 degrees. So I like to not get tricked. 90, 180, 270, 360. So now that I start here, where is my angle theta? Right there. It's a little bit small, so I'm going to use my red. So my angle theta gets formed right there. So I got to use my quadrant 3 formula. Angle theta is 187 minus 180. 187 minus 180 is 7 degrees, and we are in quadrant 3. All right, and finally, 206 degrees. There's my 90 degree, there's my 180 degree, there's my 270 degrees, and my 360 degrees with 0. I'm going to start here, past the 90 degree angle mark, past the 180 degree mark, and not quite 270, so I'm going to end up right here. And so my angle theta, yet again, is sandwiching between the terminal point and the 180 degree axis. So I've got theta is equal to 206 degrees minus 180 degrees. So if 200 minus 180 is 200, 206 minus 180 should be 26 degrees. And because we are in quadrant 3, you can check your work by comparing the cosine and sine of 26 degrees to its 206 degree angle. And you should get the same digits, but the 206 degrees should have a negative cosine and a negative sine. We'll be solving for the angles next video. So I'm very excited about that. Have a great day.